Okay, this is term 2, week 5, Math CA. Very easy. There's only the limits of the undefined integrals, indefinite integral, whatever you want to call it. Shaded region, it's revolved around the x-axis to generate a solid. How do you find the volume? Remember the volume of rotating around, it's pi integral from a to b, f of x squared, right? And for volume, it doesn't matter if it's positive or negative. Okay, so here in this case, it would be volume from 0 until pi, right? From 0 over here until pi. So pi outside always. It can be inside as well, remember? 0 to pi and f of x squared, so cosine x squared dx. Okay, and by the way, cosine x squared is cosine square x. Okay, the x is never squared in a trigonometric function. Okay, type. So obviously this one is wrong. Why is this one wrong? Yeah, because there's no pi. This one is correct because there's a pi. عادي from boundaries from 0 until pi. This is wrong because it goes from 0 until pi over 2 and it subtracts. I don't know why it subtracted the second volume. There's no reason to subtract. And then here it's the same as this one, was just pi is outside, and you guys know you can always take a constant outside of the integral. Question 2, again, same question. How do you find the volume? It's revolved around the x-axis. Okay, so you have your curve going from -1 to 2. Let me use red. Okay, so integral from -1 until 2, pi f of x squared, so x squared plus 2x plus 5 squared, right? Squared. Obviously dx. Okay, so obviously this one's going to be correct. This is negative, huh? This is wrong because there's no squared. This is wrong because there's no pi. This is correct because the pi, they just took it out. Question 3. The shaded region bounded by the curve x squared plus 1 and the x-axis to from x equals -1 is revolved around the x-axis, generate a solid, left from -1 till 2. Shaded region revolved around the x-axis. They want the volume again. Yes, remember, volume is equal to pi integral from -1 till 2, so -1 till 2, f of x squared, so x squared plus 1 squared dx. So first one's correct, obviously. Second one, there's no pi, so it's wrong. This one, they just took the pi outside, it's correct. This one, there's no square, so it's wrong. Question 4. The region bounded by the curve y equal x squared plus 3 and the line y equals 7 from x equals 0 to x equals 2 is revolved around the x-axis to generate a solid. Which of the following integrals gives us the expression for calculating the volume of the solid obtained? Here we have two y's. 2y equals something. There's two of them, right? So that means we have to use the washer method. Yes, so I got cut off, but basically here we have two curves, right? So we have, whenever you have two curves, you need to use r and small r, big R. So what does the formula say? Same thing. Volume is equal to pi integral from a to b, big R squared minus small r squared dx. Let's see. Which one's big R, which one's small r? Right now, I think it's going to be y equals 7, but let's check. We're talking from 0 until 2. So if you want to graph from 0 until 2, you can take your calculator quickly. Mode, table, right? And put in x squared plus 3, right? X squared plus 3. We know y equals 7 is always just 7, right? So if it's at 7, this is y equals 7. Okay, 0 until 2. So let's see, x squared plus 3 from 0 till 2. Forget about g of x. Okay, so it's gonna be 0, 3, 1, 4. Okay, so 0, 3, so over here. 1, 4, so over here. Yani. And then 2, 7. So it's gonna look like this. So which one's big R? Obviously, y equals 7, right? So big R is y equals 7. So big R is 7. And small r is gonna be x squared plus 3. So let's see now. Volume is equal to pi integral from a to b, r squared to 7 squared minus x squared plus 3, obviously squared dx, right? They just want the expression. So this is correct, and this is correct. Remember, whenever you have an integral of two terms, you can split up the integral and do each term separately. That's completely fine. This is wrong because the square is for both of them, which is wrong. It should be big R squared minus small r squared, not big R minus small r all squared. Okay, this one's wrong because of absolute value. Okay, and again, yeah, it's wrong because of absolute value. also because the square is outside. This one is wrong because they used small r first. Okay. Question 5. The region bounded by the curve x squared plus 2 and y equals 6. So two y's again, so two curves. From 0 to 2 is rotated around the x-axis. Which of the following is the expression? Again, same rule. Y, it's always going to be y equals 6, right? Always 6. And the other one is going to be x squared plus 2, so like this. It's going to be 1, 2, 3. You can try if you want, but this is how it's going to look. Okay? There you go. Okay, so obviously big R will be, try it on your calculator, go table mode and get x squared plus 2 between 0 and 2, you're going to get these points. It's going to look like this when you graph it. Okay, so big R is obviously going to be y equals 6, and small r is going to be x squared plus 2. So let's do our formula. It's pi integral 0 till 2, big R squared, so 6 squared minus x squared plus 2 squared dx. That's a square. Okay, this one's wrong because the square is outside. This one's correct. This one's wrong because of the square being outside. Also absolute value. Absolute value doesn't necessarily make it wrong, but it's the square outside that kind of makes it wrong. This one's wrong because they used the big R as x squared plus 2, and this one's correct. Okay, very easy. Question 6, same thing. The curve y equals x cubed and the line y equals 8 from 0 till 2. Again, y equals 8 from 0 till 2, so from 0 until 2. Y equals 8 is always going to be at 8, so always up here. The curve x cubed, y equals x cubed from 0 till 2 will look like this. Okay, it's going to look like this. Okay, some people just connect the dots, which is wrong, because this is x cubed actually looks like this. Okay, anyway, so you'll see big R is y equals 8 and small r will be x cubed, right? Again, big R because it's above it, huh? Okay, so which one is the volume of the solid? V is equal to pi integral from 0 to 2 big R squared, so 8 squared minus x cubed square dx. This is wrong because the square is outside. This is correct. This is wrong because again the square is outside. This is wrong because they used x cubed as big R, and this is correct. Question 7. The diagram below, oh, this is the famous question. The diagram below shows part of the curve 1 plus 4x to the power of half and the point A 2, 3 lying on the curve. The line AB intersects the x-axis at 5, 0. The volume of the solid revolution obtained when the shaded region is rotated 360 degrees about the x-axis is something pi cubic units. Okay, so we're going to use it the easy way, which is find the volume of this and then the volume of this separate, because they're not the same curve. Okay, they're two different curves, but you don't use washer method because they're not above each other. The shaded region only includes the x-axis and this curve, and this shaded here, the shaded region includes the x-axis and this curve. So you can kind of separate them into two. Okay, the way we do it for the first curve, how do we use our normal method, and that is our integration method, right? So we're going to do integral. The volume, always do integral. We're going from 0 until 2 pi, of course, of the function squared. So 1 plus 4x to the half. All of that squared, and the 2 cancels with the half because it's a power multiplied by a power. So you can get integral 0 to 2 1 plus 4x dx. Pi is outside, of course. Do on your calculator. I'm gonna not waste time. I'm gonna just use the integral function because I'm very you guys know at this point how to integrate and do the what's it called, do the substitution. Substitute. You know, I'm gonna do it in case. Okay, if you don't know how to integrate 1 plus 4x dx, 1 becomes x, 4x becomes 4x squared over 2. Okay, in between 0 and 2. So you substitute 2, obviously you can cancel this with this, so it's gonna come 2x squared. So you substitute 2 and then subtract it and substitute by 0, and pi will be outside. Okay, so you do this, you're gonna get 10. Okay, so this equals 10, and then we still have this part over here. This part here, it's a curve. We call it a curve. Anything is a curve. Anything is a curve when you have anything in a plane is called a curve. But it's a straight line, right? And they said use the formula 1 over 3 pi r squared h. Why did people get it wrong in the periodic? Here's why they got it wrong in the periodic. Because people used this as the height of the cone and this as the radius, which disappointed me a lot, because انت when you rotate it, it's gonna go behind, right? It's gonna go back, right? And you're gonna get a cone that kind of looks like this. Okay, so again, now you can kind of see it. The radius is actually this part up here. This is r, and the height is actually this part over here, right? So for that reason, many people got it wrong, and this question was worth, I think, 2 or 3 marks. So 1 over 3 pi r squared, remember r is the one going up, so 3 squared, times the height, which is 5. Okay, so you're probably gonna get, let's see, 15. Did something wrong, huh? Did I do something wrong? Let me see. 1 over 3 times... Oh, akid, it's not 5. The height is not 5, huh? Sorry. It goes from 2 until 5. That means the height is 3. I don't know how I got 5. Sorry, huh? Times 3, and yeah, you should get 9. Yeah, you'll get 9 if you do it. You'll get 9 pi, huh? The one up here also, it was pi. Add these, you get 19 pi. Let's speed up a bit. How many questions? 19. Question 8. Okay, this question, famous question, always comes. They want you to find k and m. Okay, so he told us this function is k squared plus m. Point A has coordinates 1, 6, and point B has coordinates 2, 18. Okay, so if you substitute 1, 6, 1 into this, you should get 6. So if you substitute 1, so as x, right? So 1 squared, it's k times x, right? So k times 1 squared plus m is equal to how much? 6. Okay, and we know that k times x squared, now substitute this one here, 2 squared plus m equals 18. So let's solve this. You're gonna get k plus m equals 6, and then 4k plus m equals 18. Over here, you can simply just subtract these two equations by each other, or you can take k to the other side and use the traditional method. M is equal to 6 minus k, so you put 4k plus m, which is 6 minus k, is equal to 18. 4k minus k is 3k, plus 6 is equal to 18. So you get k is equal to 18, 12 to 4. Okay, and we know m is 6 minus k, so it's going to be 6 minus 4, which is 2. Okay, so k is 4, m is 2. So now we know what m and k is. They're asking for the volume of the shaded region around the y-axis. Huh? So this function f of x is kx squared plus m, where we know that 4 is k. So 4 is, so if you substitute k and m, you get 4x squared plus 2. So this is the function, right? In terms of y. But now they're saying rotate it around the y-axis. So please don't forget around the y-axis. That means you have to make it in terms of y. How to make it in terms of y? Take 2 to the other side. It's going to become y minus 2 equals 4x squared. Divide by 4 on both sides. You're going to get y minus 2 over 4. And square root both sides. You're going to get root y minus 2 over 4. Now you want to integrate this around the y-axis. Huh? So we want the shaded region around the y-axis. What are our boundaries with respect to y? We're going from 6, this is over here at 6, up till 18. So our boundaries are integral. Remember, pi outside. We're finding the volume from 6 until 18. Y minus 2 over 4 under the square root squared, right? dy. Square with root, you're going to get integral y minus 2 over 4. So it's the same as saying integral y over 4 minus 1 over 2, because 2 over 4 is, you know, let me not complicate anybody. Minus 2 over 4. Okay, I just split it up from 6 till 18, and I'm sure you all know how to integrate. This is going to become y squared over 8 minus 2 over 4 y. In between 6 and 18 with pi outside. So let's put this on a calculator. If you do this, I'm going to do it over here. Integral y minus 2 integral y minus 2. So we can just say x minus 2 over 4. Same as saying divided 4. Boundaries from 6 till 18. You get 30. Okay, so the answer is 30 pi, which is correct. Okay. Question 9. Find the values. Okay. لا بلاش with improper integral. Okay, the thing is with integrals, we're gonna start with integral, and I'm gonna solve this one over here. Okay, integral 1 till infinity 15 over root 5 dx. 1 until infinity 15 over root 50 root dx. Okay, 15 over 5th root x dx. Someone's gonna see this integral, he's gonna say, oh, how, what's this infinity? Wow, what's this? It's the same thing as integrating normally, but here we're just saying the bounds approaches infinity. So what we're trying to say is this integral, does it approach any number when it approaches infinity? Okay, how do you solve this? Simple as it's so simple. So integrate normally. You just integrate normally, really. So 15 x to the power of minus 1 over 5. Remember, integral 1 till infinity, right? dx. Integrate it, you're gonna get 15 x to the power of 4 over 5 over 4 over 5, and you're gonna get 60 over 4, not sure 60, you're gonna get 75 over 4 x to the power of 4 over 5. What are our bounds? From 1 until infinity. This is the step people will be like, okay, how do I substitute infinity? If this is a written part, you're gonna say let, okay, sorry. It's what you should have done earlier. When you rewrite it, when you solve it, instead of writing infinity, what we do is we write it as b, and then you later say let b approach infinity. Okay, wait, let me show you. So instead of infinity, what we write is approaches b. Okay, and you integrate normally, and you're gonna say here it's up till b. Okay, and then you're gonna say let limit b approach infinity. Okay, and you're gonna write an arrow such that 75 over 4 infinity to the power of 4 over 5, right? We're substituting now, minus 75 over 4 times 1, right? Basically 1, because when you substitute 1, it's going to be 1. So you're going to see here now, do you have infinity in your answer? Because when you do infinity to the power 4 over 5, you can get infinity. Infinity times a number is infinity, and then infinity minus a number is just infinity. So that means the integral, does it approach any number if you ended up with infinity? No. It just keeps on getting bigger and bigger and bigger. So you say the integral diverges. So over here, they said if an integral diverges, enter 999. So you put 999. So that's the first case. That's what we call type 1 of the improper integral. Okay, very simple, very easy really. The second type is what I'm going to show you now. Integral 1 until 0, what was it? 8 over 5th root x. 8 over 5th root x. Okay, dx. Again, same thing, you should just integrate, yeah? Yeah, so you integrate. Same thing. Let's integrate is going to be 8 integral 1, 0, 8 x to the power of 1 over 5, and negative 1 over 5 dx. Integrate, you're going to get 8 x to the power of 4 over 5 over 4 over 5. Cancel this with this, you're going to get 2. You're going to get 10 x to the power of 4 over 5. Do it on your calculator if you don't believe me. Between 1 and 0. X to the power of 4 over 5 means 10 root 5th root of x to the power 4 from 1, 0. Wait, I just realized it's from 1 until 0. It doesn't matter. Over here, over here, over here, over here. Okay, type from 1 until 0, 1 until 0, 1 until 0, whatever. Okay, so now you substitute. You can go 10 root 1, obviously 5th root of 1 to the power 4, minus, obviously when you substitute you get 0. So you're gonna get 10. So your answer, you say if this was in a written part, the integral converges at 10. Simple as. So easy. Question 10. Okay, there will be other cases. This is just to know. You're gonna think, oh, Polito, what the fuck's the point of this? Why'd you do this? You're gonna see later. I'm pretty sure there's more than one question. Yes, this trapezoid rule, yeah, over here, these three. Okay, find the area of the shaded region. Okay, area, خلاص, we know how to do this. Obviously for area you have to separate above and below the x-axis, right? So this is x minus x squared over 2, right? Because remember, what divides by it is what's in, if it was in the brackets like this, and it would be all over 2, but no. Okay, anyway, so now here you do the integral, right? You want to find area, you always integrate between your bounds 0 and 2 first, right? 0 and 2, x minus x squared over 2. Let's integrate the x. You're gonna get x squared over 2 minus x cubed over 6. Very easy, right? Between 0 and 2. Then you have from 2 and 3, so integral to 3, x minus x squared over 2, which we found the integral to be x squared over 2 minus x cubed over 6, right? So x squared over 2 minus x cubed over 6 in between now 2 and 3, right? So you do this on your calculator. Okay, we're first going to do integral from 0 to 2, x minus x squared over 2 in between 0 and 2 first. You're going to get 2 over 3. And then the other one you're gonna get, obviously you're not allowed to do this in the exam, huh? I'm not in the mood whatsoever to substitute and plug in numbers. You can get minus 2 over 3, which is expected, huh? You're gonna get minus 2 over 3, but you make it positive, so you get 2 over 3. So you add these two now, you get 4 over 3. You should get a negative answer for when it's below, huh? Like, it's normal, don't panic. The area of the region enclosed by y equal x squared minus 5x plus 6 is something. خلاص تعبت, man. We keep on doing these questions, area. خلاص, it's been 3 weeks. Between two curves, always when you're finding area, you subtract, right? So integral from a to b, and you subtract the curves. X squared minus 5x plus 6 dx. But someone's gonna come say, what are the bounds? Of course, to find the bounds, you equate both equations to each other. So let's equate both equations to each other. You're gonna get a quadratic, which you can solve easily, and you're gonna get two solutions, 3 and 2. 3, no, not 3 and 2. Two numbers, 1 and 5, sorry. So 1 and 6. So you're gonna get x plus 6, x minus 1 when you factor. So your answers are negative 6 and 1. So your a and b will be integral negative 6 until 1, x squared plus 5x minus 6 dx. And you start substituting. I'm not gonna substitute, you do it yourself if you want, but I'll integrate it for you. So it's gonna be x cubed over 3 plus 5 over 2x squared minus 6x in between negative 6 and 1. Let's make sure. X squared plus 5x minus 6, 5x minus 6 in between negative 6 and 1. You get minus 243 over 6, which you change to 343 over 6. And they're asking for k, so it's going to be 343. Question 12, speed up a bit. The region bounded by the curve 3 root x and the line y equals 3 from x equals 0 to x equals 1 is revolved around the x-axis to generate a solid. What is the value of k if the volume of the solid obtained is k over 2 pi? Okay, rotation around the x-axis, but you have two curves. So what do? Graph. Y equals 3, of course, will look like this, right? We're saying from 0 until 1. 3 root x looks like this, okay? I'm gonna give you the calculator. We're gonna put it table mode because I won't, like, it's a bit hard. So 3 root x, okay? The thing is with 3 root x, don't go from 0 till 1 directly. Go from 0 till 1 using a smaller step than 1, okay? Use step as 0.5 because it changes, okay? So you could say, no, anyway, actually, it doesn't matter if it changes or not. We're going only from 0 to 1. Anyway, so 0, and then, obviously, at point 1, you're going to have 3, and at point 0.5, you have 2 points, so it's over here. Obviously, it's not a straight line, huh? It's a curve. Okay, heck. Okay, so we want this shaded here. Or no, between the x-axis. It's revolved about the x-axis to generate. Yeah, so they want the volume of this, right? What's the volume? We need to see which one's big R, which one's small r. In this case, it's y equals 3 is big R, and small r will be 3 root x. So let's do integral from 0 till 1, big R squared, so 3 squared, minus small r squared, so 3 root x squared dx. So you're going to get 9 integral from 0 to 1, 9 minus 3, 9x. Why 9? Because 3 squared is 9, root x squared is x. Okay, dx. Integrate, you're going to get 9x minus 9 over 2x squared. In between 0 and 1, I forgot the pi, guys. Don't forget the pi. And you're going to get, you should get, let's check on our calculator. Integral 9 minus 9x in between 0 and 1. We should get 1 over 2. No, I'm sorry, 9 over 2. Yeah, there you go, 9 over 2. So k is 9. Question 13. The region bounded by the curve. The region bounded by the curve y equals minus x. How many questions of this stuff we have left? Okay. The region bounded by the curve y equals minus x squared plus 2 and the line y equals 1 from x equals 0 to x equals same thing, all the same thing. Two curves, right? Two y's. So we're gonna draw them again. Y equals 1 looks like this. Minus x squared plus 2. Let's see, from 0 until 1, no? 0 until 1. So minus x squared plus 2. It should be above it, صراحة. From 0 till 1. So 0, 2, 2, 1. So 0 over here, 2, 2, 1. So 0 over here, 2, 2, 1. Okay. As a 1, 1, 1, sorry. So 0, 1. Okay, so it looks like this. So which one's big R? Obviously, minus x squared plus 2. Which one's small r? Y is equal to 1. So let's do the formula pi integral from 0 till 1. Big R squared, so minus x squared plus 2 squared minus small r squared dx. Okay, and then akid, if you want to do this, you have to expand this. So you're going to use it as if it's a minus b squared. So you're going to do x to the power 4, which is a squared, minus 2ab, so minus 2 times x squared times 2, plus b squared, so plus 4, and then continue this, minus 1, and then don't forget the integral, and pi, that's it. Okay, simplify this a bit. 4 minus 1 is 3. Okay, this is going to be minus 4x squared. Just simplifying, you guys don't have to do all of this. Okay, now integrate. So x to the power of 5 over 5 minus 4 over 3x to the power of 3 plus 3x in between 0 and 1. Pi is outside, of course. Let's do it on the calculator. I'm just gonna put in this on. So integral x to the power of 4 minus 4x squared plus 3 in between 0 and 1. We should get 28 over 15. Yes, we did 28. Question 14, I think no more. Oh my god. The region bounded by this curve, and this curve is revolved from x equals 0 to x equals 4. Okay, whatever. So from x equals 0 to x equals 4. The line y equals x, if you want to put it in table mode, it starts 0, 0, then 1, 1, then 2, 2, then 3, 3, then 4, 4. This is the line y equals x. Okay, you don't trust me, put it in your calculator. Y equals root 2x, honestly, this one I gotta put it in my calculator. Okay, so mode 7 root 2x. Okay, let's see, forget about g of x. We're going from 0 until 4. Let's graph it slowly. 0, 0, 1, 1.4, so it's up here. Okay, 2, 2, okay. And then 3, 2.4, 4, 2. Okay. So 3 is over here, 2.4, 4, 2.8. So it actually looks like this. So as you can see, this was a book question. As you can see, we have two phases. We have the big R and small r. It actually changes. So during from x between 0 and 2, root 2x is big R, right? But after that, y equals x becomes big R. So let's say for x in between 0 and 2, okay, r is gonna be root 2x, and small r is gonna be y equals x. And then for x in between 4 and 2, right? The big R is gonna be y equals x, and the small r is gonna be root 2x. Okay, perfect, guys. Hella, you have to split up the integrals, obviously, because big R and small r changes. So let's start for first between 0 and 2. So pi integral big R minus small r, so root 2x square minus x square dx. So cancel root with the square. So it's going to be pi integral from 0 to 2 to x minus x square dx. Okay, you're going to get x squared minus x cube over 3 between 0 and 2 with pi outside. Okay, let's do this fast. Table as the integral x squared minus x cube over 3 from 0 until 2 first. So you get 4 over 3 for the first one. The second one, again, integral 0 till 2. Big R now is x, so x squared minus root 2x squared dx. Again, obviously square with square with the root, so pi integral 0 to 2 x squared minus 2x dx. Integrate, you can get x cubed over 3 minus x squared between 0 and in between 2 and 4 now, because we're solving between 2 and 4, right? 2 and 4, 2 and 4. So now do integral. It's x square minus 2x in between 2 and 4. You get 20 over 3. You add both volumes, you're going to get 24 over 3, which is actually 8. So add 4 over 3 and 20 over 3, you get 8. Question 15, هلا trapezoid rule, right? Okay. Using the trapezoidal rule with n equals 4, what is an approximate value of this? So this is the trapezoid rule, which I'm going to explain on the whiteboard. I kind of forgot it. Like it's not very, like, you know, this is where integration in its pure came from. So I'm not gonna waste time. I forgot it because we did before the break, so I had to reread it now and like go back and understand. Okay, basically, I'm sure you all know that. Let's say you have a curve like this, and whatever. Okay, and let's say they asked you to integrate it. Okay, basically where the integral came from, and I explained this many times before on my channel, is let's say they wanted you to find the area of this shaded region. So what we would logically do is find the area of it. Let's say we don't know how to integrate, we'd find the area of it, and these curves we'd kind of like add small boxes and whatever and whatever. So basically what they decided to do, our famous mathematicians, is that they first started with something called the trapezoid rule. If you realize, if you divide these into intervals, these are actually trapezoids. Let me show you. If you look here, from here to here, I'll draw it in green, right? And it's from here to here, over here to here, from here to here. Yeah, that's pretty much it. So if you realize, these shapes are trapezoids. Yeah. Gonna wait. Let me pause to when I draw them. Or no, it's fine. Okay. Anyway, so basically what they decided is that this can actually give you an estimate on what the integral can give you. Why? So you're gonna be like, Tobolidio, it's actually gonna be a bit bigger because here it goes up. So, okay, here it goes above, but here it actually goes below, and also here it goes below, and here it goes below. So what you added extra here could be accounted for in these plateaus. Okay, so it's completely normal. You might be confused, but anyway, how this worked is they found the area of all of these trapezoids and added them all. So let's call this x0 and let's call this xn. Okay, let's say I want to integrate from a to b of any function f of x, right? Type. So let's call x0 a and let's call this b, and this is exactly what they do. They divide it into subintervals. Okay, in the question they'll always tell you how many subintervals. Okay, so if you find the area for each one, let's call this x0, let's call this x1, because what comes after the 0, 1. Let's call this x2, let's call this x3, and let's call this x4. Okay, Basically, from x0 to x1, what's the area of this trapezoid? The base one is this, okay? We're gonna call it f of x0. And then base 2 is f of x1. F of x basically means y, huh? So like the value of y at that coordinate, right? Because this is base 1, this is base 2 going up. Then what's the height? The height will be between x1 and x0. So let's just label it as height. Okay, I don't want to say x1 minus x0 because it will complicate you, and later on I'll explain it a bit easier. Okay, the second one here is x1 from x1 to x2. So again, the base one will be f of x1 plus base 2 will be, sorry, this should be over 2, huh? Remember, the area of a trapezoid is base 1 plus base 2 over 2 times height. Then here, base 2 will be f of x2 over 2 times the height. Then the second one, f of x2 plus f of x3 over 2 times the height. Then the last one, f of x3 plus f of x4 plus f of x4 times over 2 times the height. So if you realize, f of x1 is repeated twice. Then f of x2 is repeated here and repeated here. F of x3 is repeated here and repeated here. The only thing not repeated twice is what? The first one and the last one. So our famous mathematicians came and they did this. They saw the 1 over 2 in common, so they took 1 over 2 out. They saw height in common, so they took height out. I'm just going to replace this one with h. Okay? They now opened the bracket. They saw now inside the bracket, they left f of x0 the same because it didn't change. They saw inside the bracket that every value of f of x is repeated twice except for the first and last. So they kept the first one normal, and every other one they multiplied by 2. So 2 times f of x1. So we're done here. We're done with these 3. 2 times f of x2. We're done here. And then 2 times f of x3. And then the last one will be just f of x4. Why not 2? Because it's the last one. It's just repeated once. And we close our bracket. Just like that, we found all the areas, and this is an estimation for this integral. So this is where the rule comes. Integral from a to b across n subintervals, across n intervals of any f of x is equal to h over 2 f of x0 plus 2 f of x1 plus 2 f of x2 and so on until 2 of f of x, the one before the last, we call it, let's say this is the last one, we call it, remember we called it xn, yeah? The one before the last, we call it n minus 1. So the one before n, okay? And the last one, you don't multiply it by anything. F of xn would be your last one. You don't multiply it by anything. It stays 1, and you close your bracket. So this is your formula for the trapezoid rule. Where? Someone's going to ask, what's h? h is equal to b minus a divided by n. You can say, why? Because we want, now in my diagram, it's not spaced evenly. We want these heights to be equal because you're multiplying it by the whole equation. So you want the height to be equal. For that reason, you take the last number, you take the first number, you subtract them by each other and divide it. Let's say you want 4 intervals. You take, let's say this one's 1, this one's 5. You take, to find what h is, you do the last number minus 1 and the first number, and you divide it. How many times do you want to divide? How many squares do you want? You want 4. Okay? What's important to know? There are a few things important to know. If I tell you I have 4 intervals, that means I want 5 numbers. What do you mean? I'll explain to you. Let's start here. Using the trapezoid rule with n equals 4, what is an approximate value of integral 0 to 4? What's the approximate value? So integral 0 to 4 dx 3 over 3 plus x squared. What's nice about here, you do absolutely no integration. 0, 0, 0 integration. Okay? Because what does the rule say? The rule says integral of f of x, you directly take f of x down and start substituting. So let's see. What's our rule? Our rule for trapezoid is h over 2 f of x0 plus 2 f of x1 and so on until you reach f of xn minus 1, the one before the last, which is also multiplied by 2, and then f of xn you don't multiply by anything. We're done. What do we need? We need h. How do you find h? It's always b minus a over 2. So 4 minus 0 over, sorry, not over 2, over n. How many subintervals do we want? 4. Okay, so you get 1. So h in this case is 1. So 1 over 2 into, now we start substituting. You're going to say, Tabulid, how many numbers do I use? That's a nice question. We said 4 subintervals. The amount n, always f of xn, right? I always said f of xn. In the book they call it, I think, f of xi or something like this. N will always be equal to, I think it should be, wait. N is equal to 4. N is equal to 4. But for that reason, but why do we take 5 numbers? Because I start counting from 0. Okay, so 0, 1, 2, 3, 4. Okay, but in total I have 5 numbers. Since I start counting from 0, if you want 4 intervals, you need 5 numbers. So let's start. That means we're gonna take the first number. We're starting at 0, right? So we're gonna start at 0. What are we increasing by? 1. 1. Increase again by 1. 2. Increase again. 3. Increase again. 4. Just like that. We finished at 4. And we have how many numbers? 5. Just like we wanted. So we're gonna substitute each one of these into f of x. Okay, so this integral is pretty much useless. The only thing I use from it is the bounds and f of x. What is f of x in this case? It's 1 over 3 plus x squared, right? That's what f of x is. So you substitute now 0, 1, 2, 3, 4. If you want to make your life easier, instead of substituting 1 by 1, go to calculator, go to table mode, go to 1 plus 3 plus x squared from 0 until 4. And you get all values. So 0 will get you 0.3, so in other words 1 over 3. 1 will be 0.25, so in other words 1 over 4. 2 will be 0.1428. Okay, and then 3 will be 0.0833. Okay, and then 4 will be, so we have a problem here. What's the problem is the calculator gives you decimals. So don't use this method. Don't use the calculator like this. You actually have to do it 1 by 1. I'm sorry, huh? So you have to do it 1 by 1. So 0, we substitute 0. Obviously 0 will get you 1 over 3. That's pretty obvious. Okay, substitute 1, you'll get 1 over 4. Substitute 2, you're gonna get 1 over 5. Is it 1 over 5? No, you'll get 1 over 9, sorry. 1 over 7. Because 2 squared is 4 plus 3 is 7, so 1 over 7. Substitute 3, you're gonna get 1 over 12. Substitute 4, you're gonna get 1 over 17. Okay, طيب. Now you have f of x0, f of x1, whatever. It's very easy. F of x0, so 1 over 3, plus 2f of x1, so 2 times 1 over 4, plus 2 times 1 over 7, plus 2 times 1 over 12. We're on the last number now, so you can't multiply by 2 anymore. Okay, and you close. Put this all on your calculator. You should get 89 over 133, but let's try it. 1 over 2, open bracket, 1 over 3, plus. Let me speed this up, huh? Okay, I just want to pose that 4 squared plus 3 is not 17. It's 19, huh? So let me fix this. It's 19 over here. 19. Okay. You get 89 over 132. So now that we explained it, I can move on a bit quicker with the second one. So what's nice here is that they actually gave you the table. Use the trapezoid rule to estimate for 1, 2, 3 f of x dx. Enter your answer as decimal number. So how do we do it? They gave you how many subintervals. They didn't give it to you directly, but you can find it. 1 value, 2 values, 3 values, fourth value, 5th value. Pause the video and try and give a guess onto how many subintervals. What's my n gonna be equal to? The answer is n is equal to 4. Why? Remember, we start counting at 0, so you're always going to have one more value than the amount of n's. Okay, so n is equal to 4. How do we do it now? Let's apply the formula very easily. We have the numbers already given, so it should not take you any time. So start with the h over 2 f of x and continue on, plus 2 times something, whatever. So f of x0 plus f of x, 2 times f of x1 plus so on and so on until 2 times f of xn minus 1 plus f of xn, right? Okay, let's see. H is always equal to b minus a over n. So 3 minus 1 over n, which is 4. So which is, in other words, 1 over 2. Okay? So in other words, it's 0.5. So h is 0.5. Okay, so don't keep it as a fraction, keep it as a number. So 0.5 over 2. Start. F of x0, 1 plus 2 times 1.8, right? 2 times 1.8 plus 2 times 2.3 plus 2 times 2.9 plus 3.2 without multiplying by 2 because it's the last value. Now, put this in our calculator. Let's go. 0.5 over 2 times 1 plus 2 times 1.8 plus 2 times 2.3 plus 2 times 2.9 plus 3.2. You're going to get 91 over 20. As a decimal, it's 4.55. Question 17. Consider the improper integral to positive infinity 120 over x4. If the integral converges, give it the value. If it diverges, enter 999. Let's do it. Integral to positive infinity 120 over x to the power 4 dx. One thing I forgot to mention over here, when you say limit, okay, when you say limit, actually no, forget about the limit. Forget about the limit. What I said now, forget what I said. Okay. Anyway, 120 over x to the power 4 dx. Remember, for infinity, we always replace infinity with b, okay? And we say and solve the integral. So it's going to be x minus 4 dx. Okay, so the integrate is going to be x minus 3 over minus 3, 120, right? Now we go from 2 until b. Simplify, you're going to get minus 40 over x cubed in between 2 and b. We're going to say let limit of b approach infinity, and you're gonna now solve normally. You can get minus 40 over infinity minus open bracket, substitute 2 now, minus 40 over 2. Some people, they don't understand what this limit b infinity whatever. It basically means you solve as a b and then change b with infinity. Okay, that's literally it. Okay, minus 40 over infinity is what? 0, because any number divided by infinity is 0. 0 minus minus 40 over 2 is minus 20, so you're gonna get 20. And I obviously did something wrong over here, but give me a sec. It's minus 40 over it. I substitute 2, it should be 2 cube. I don't know why I didn't put 2 cube. Okay, so you're gonna get 0 again, minus, instead of minus 20, it's minus 5. So you're gonna get positive 5. Extremely easy, guys. Question 18. Okay, again, same thing. So what do? Copy it down as b. Okay, and then 192 x to the power minus 5. Remember, integrate normally. Okay, you're gonna get 192 x to the power minus 4 over minus 4 in between 2 to b, right? 192 divided by minus 4. Let's keep our work neat. It should be actually 48. It should be 250, 48. It should be negative 48. Okay, x over x to the power 4. Why over x to the power 4? Because the power is negative, so it goes down. Okay, in between 2 and b. Type. You start. You say limit b approaches infinity. Okay. And then you draw an arrow and solve. Minus 48 over infinity. Okay. Then substitute 2. Minus, open bracket, minus 48 over 2 to the power of 4. And you should get 3, but let's see. Yeah, you should get 3. Because minus 48 over infinity, any number over infinity is 0. Minus, over here you get negative 3. So you get equals 3. Okay. Question 19. Consider the integral again. If the integral converges, find its limit. If it diverges. If you get like we did earlier, if you get in your answer infinity, that means it diverges and you enter 999. Okay, and let's consider improper integral over here. This one, 30 over x7, again, integrate, but change it to be 30 x to the power of minus 7 dx. Integrate, you can get 30 x to the power of minus 6 over minus 6. You're going to get minus 5 over x to the power of 6 in between 1 and b. Then you say limit b approaches infinity. Okay, you're going to get minus 5 over infinity minus open bracket minus 5 over 1, and obviously you get 5. Thank you so much for watching and good luck in your exam.